got to give the people. I want to give the people what they want. All right, Bass, hit you with that remix real quick. You know what it is. 2.1, everything to know about quadratics. Almost everything to know about quadratics. So we're going to have 3 learning targets on our test that you should be writing down. 1, can you factor quadratics to solve them, to find the roots, to find the x-intercepts? That's all the same thing. 2, can you complete the square to solve quadratics, to find the roots, to find the x-intercepts? All the same thing. And 3, can you convert and graph from all forms of quadratics? Meaning I can find roots, I can find x-intercepts, I know where the vertex is, I know everything. So let's hit number 1. For number 1, why don't you do this before me? Why don't you factor this? Look back at your notes. This is what y'all kind of seemingly forgot in that exit ticket. So let's see what we got here. So cool, you went through your notes, you look back, you tried to factor it. Again, this is area model situations. First thing I'm going to do is I'm going to look for a GCF. There is no GCF, so I'm going to go, okay, boom, 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 boom. I know this has to be 2x squared. I know this has to be 9. I know that these two things have to add up to -9, and I know that these same 2 blanks have to multiply to whatever 2 times 9 is, which is 18. Okay, let me go ahead and do this. 18 minus 9. So now I'm thinking my factors of 18. 1, 18, 2, and 9, 3, and 6. 3 and 6 look good to me. I bet I could somehow turn those into a -9. So let's see. 3 times 6 is 18, and 3 plus 6 is not -9, so that doesn't work. -3 times -6 is also 18, and -3 plus -6 is -9. All right, that works. -3, -6. Now I'm here. The only way I can get, now I'm here. I got to get 2x squared. The only way I can do it is 1x times 2x. So where does it make more sense to put the 2? Probably here. 2x, 1x, because I can see this and this are both divisible by 2. So 1 times 2 is 2, x times x is x squared. Now to get this spot, 2x times... Oh, that's supposed to have an x. There we go. That's what's wrong. 2x minus 3 is -6x. And I just figured that out. To get this spot, 1x minus 3 is -6. -3x. Okay, so now I have my factorization. I factored it. I end up with 2x minus 3 times x minus 3. Boom, boom, boom. I am feeling pretty good. All right, so let's see what is next. It says factor that. It's factored. And now from here, if I said factor it and solve for the roots, if asked to solve for roots, what do? I set it equal to 0. So if I asked you to solve for the roots, then you'd be like, oh, okay. Well, this is the factored form. Boom, boom. If I want to set it equal to 0, that means 0 equals 2x minus 3 and x minus 3, which means that either 2x minus 3 has to equal 0 or x minus 3 has to equal 0. So if I go ahead and finish this off, plus 3, 2x equals 3, divided by 2, divided by 2. X equals 3 halves. That's my first root, slash x intercept. Or, plus 3, x equals 3. That's my second root, slash x intercept. But this one just asked you to factor, so that is it being factored. Just giving you that little extra fresh information for fun. Boom. Number 2, complete the square to solve / find the roots. All right, so again, it didn't ask me to change it to vertex form. It asked me to find the roots, so I'm going to go ahead and do that. So if I want to ultimately solve this, I'm going to be like, okay, again, roots are when the output is 0. So we have x squared minus 10x plus 7, just like when we were in factored form. But now I'm going to do that whole completing the square thing. I'm going to be like, okay, let me move this 7 over. And I end up with negative 7 equals x squared minus 10x. And here is where I'm going to complete the square. Which you should be like, oh, okay, what do I have? I have this negative 10, right? I have to take that negative 10 and divide it by 2, which gives me negative 5. And I have to take that negative 5 and square it, which gives me 25. Cool. So you're like, all right, well, what do I do with that? So this becomes plus 25 on this side. And to keep this even, I'm going to put plus 25 on the other side. Right? It kept my equation balanced on both sides. Really, I didn't add anything to each side because I added the same thing to both sides. So they're both balanced, both equal. And the whole reason I did this is because I created a perfect square, which is why this is called complete the square. So it is, what is it? X minus 5 squared equals whatever 25 minus 7 is, what's that? 18. X minus 5 squared equals 18. Now we're looking good. Again, if I said find the roots, that means I'm solving for x. So what do I need to do now to get x by itself? I need to take a square root, and I need to take a square root. So the square root of 18 equals x. Remember, we took the square root because that cancels with that. X minus 5. And remember, it's the plus or minus square root of 18. So now I'm going to go ahead and add 5. Add 5. I end up with x equals 5 plus the square root of 18. Or x equals 5. Remember, it was plus or minus. Minus the square root of 18. Yeah. Those are my two roots / x intercepts. Yeah. One to go. All right, one more. Now, why don't you try this and try to convert to all three forms of the quadratic. Oh, good. So here, why don't you try to do it? What form is this in right now? Whatever form this is, try to turn it to a different form. Then when you get a different form, try to turn it into the third form. All right, so you tried it, you worked really hard, and you tried to make it happen. Let's see how you did. So let's see. First of all, this is factored form. Nice thing about factored form is if I want to do factor form, I can just multiply it to figure out standard form. So I'm going to try to turn this thing into standard form. So I'm going to take the factors. I'm going to take x minus 2 times x plus 4 to get me standard form. X squared, 4x minus 2x minus 8. I have x squared negative 4 and 4 and negative 2 is plus 2x minus 8. Look at this. That equals f of x, and that gives you standard form. All right, I got a factored form. I just did the area model. I multiplied those factors. I turned it into standard form. What's my last form? I got to figure out vertex form. Oh, I got to use completing the square, but I'm going to do it in a slightly different way. So I'm going to say f of x equals x squared plus 2x minus 8. And I'm going to complete the square, so I'm going to go ahead and keep writing this. I'm going to say x squared plus 2x plus blank minus 8. Then I'm going to take this middle term, 2, and I'm going to divide it by 2, and I get a 1, and I'm going to take this 1, and I'm going to square it. I get a 1, so I'm going to add a plus 1, and I'm going to add a minus 1. Remember, got to keep it even. So plus 1 and minus 1 means I really didn't add anything, which means I'm still in balance. So now I'm going to take this part, and that's the perfect square that I created. So at this point, f of x equals, what is that? X plus 1 squared. And then I have negative 1 minus 8, which is minus 9. So what do I have now? This is vertex form. I went from standard form to, I went from factored form to standard form to vertex form. I have all the forms there. Now I could be like, well, what are the roots? I could find any way I want. I could find the factors from factored form to get roots. What is the vertex? I can figure that out because I see it right here. So let's go ahead and get those key features. The key features I have to know are I need to know the roots and I need to know the vertex. Well, I can see the vertex in vertex form. So I should see that the vertex is, don't forget, when we're talking about the vertex, it's negative 1, negative 9. That is the vertex. And then if I wanted to find the roots, I could do that. I could get that from factored form. The roots mean that either x minus 2 equals 0, so plus 2 plus 2. So either one of the roots is x is 2, so 2, 0 is one root. And the other root says x plus 4, that has to equal 0, minus 4, minus 4. So my other root is negative 4, 0. That is everything. We got more work to do on this. Y'all been holding it down. Mr. Bass, I'm out.